Welcome to our hands-on lesson on setting up network policies to control traffic between containers. As we dive deeper into Docker security, controlling and isolating network traffic among containers emerges as a crucial strategy. In this lesson, we are going to learn how to implement network policies to enhance the security and efficiency of our Docker environments. Let's begin our journey to mastering Docker network isolation. In a containerized architecture, network policies are essential for securing container-to-container communications. They help prevent unauthorized access and ensure that containers can only communicate as per our defined policies, thus reducing the risk of internal threats and data breaches. In this lesson, we will focus on utilizing Docker's built-in network features to achieve this goal. Docker provides several network types out of the box, including bridge, host, overlay, and none. For custom isolation and communication rules, creating user-defined bridge networks is often the preferred approach. These networks provide automatic DNS resolution between containers and allow for better control over traffic flow. Let's start by creating two user-defined bridge networks to segregate our container traffic. So right now we will create two separate networks, network 1 and network 2. So let's type docker network create network 1. And we will create network 2 using the same command. So these commands create isolated networks, allowing us to control which containers can communicate with each other. Next, we will run two simple web server containers, each attached to a different network. To demonstrate, we will deploy an Nginx container on network 1 and an Apache container on network 2. Let's start with the Nginx container. So let's execute docker run -d --name nginx underscore container -network. Then we will create this container on network 1, and the image we will create the container from is nginx. I will execute the same command for Apache, but I will change the name of the container to be Apache container and the network to be network 2. And the image I will create the Apache container from is httpd image. Now press enter and let's docker ps. And as you can see, we have two running container, Nginx container and Apache container, and both of them attached to a different network. To verify our network isolation, let's attempt to ping Nginx container from Apache container. Since they are on separate networks, this attempt should fail, confirming our isolation policy. So let's get into Apache container shell by executing docker exec -it, then Apache container, then bash. But before executing the ping, let's first inspect the IP of Nginx container. So I will take the ID and I will execute docker inspect, then the ID of the container. And here is the IP address of Nginx container. Let's copy it. Now let's exec to the Apache container again. And let's execute ping, then the IP of the Nginx container, which is 172.24.0.2. Now press enter. And as you see from the output, we don't have the ping command. So let's install it. So to install ping, I will execute apt install IP utilities -ping. We need to update the packages first. So I will execute apt update. And after apt update, I will execute apt install IP utils -ping. Now let's ping the IP of Nginx container. And as expected, the ping fails because Apache container cannot see Nginx container due to our network isolation. For more granular control, you can implement custom network policies using third-party tools like Calico or Kelium. These tools allow you to define precise rules about which containers can communicate based on criteria such as labels, ports, and more. While setting up these tools is beyond the scope of this lesson, I encourage you to explore them further to enhance your Docker network security. And by that, I can say congratulations. You have taken an important step towards securing your Docker environments by learning how to set up network policies to control traffic between containers. These practices are crucial for maintaining a secure and efficient containerized infrastructure. Thank you for joining this lesson and see you in the next one.